Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, Episode 23, Hadoop. Take it away, Jason.
Hey everybody! So we actually got a pretty awesome question from the audience that we want to kind of start.
We have an audience? I thought it was just you and me and our moms.
So yeah, our mom had this awesome question. It was, "How's it going?"
Wait, not our mom doesn't make any sense.
Oh yeah, no, never mind.
Your mom? My mom? This sounds like we're making bad mom jokes, but I'm not really.
Yeah, I think I just dissed my own mom. Anyway, so Marco Aurelio sent in a question, and he's looking at doing some C#.net coding for a website that he's interested in making. And he was sort of interested. His question was, he knows that server-side stuff, the code and the CPU is used on the server. And so if you have, one user, you're using some amount of CPU. If you have 1,000 users, you're using, maybe not 1,000 times, but the CPU scales up, right? So his question is, how can big websites, is it true that big websites like eBay and Amazon and things like that, run things on the server side, and how do they do that? And how does the server not explode? And then along those lines, what languages should he focus on learning?
Yeah, so it sounds like he had a question there. He has an idea. And so his idea was to kind of build a website, but he's worried about it scaling, what technology he's going to choose.
Yeah, totally.
So I have a slightly different answer, and mine is that I think sometimes in the tech community and as engineers, you over-engineer things. So this is a classical problem. And so having the issue where you can't scale your website because you're growing too fast would be a very good problem to have. I mean, there are certain things you don't want to do to aggravate it, or especially if you get to the point where somebody's funding you or you're making a lot of money and your website goes down and people are depending on you, that's a really bad problem.
Right.
But when you just have an idea, it is more important to get the idea out there, to start working on it, to find other issues like, okay, I need to shift this idea slightly, or I need to do this, than to spend tons and tons of money trying, if you ever read about some of these people that started Google, it was two guys and some university equipment, or, Mark Zuckerberg at Facebook, it was just running in his dorm room off his computer, right? None of these things started with I'm going to start with 10,000 computers and I'm going to serve millions of... that's how you go bankrupt, right?
Did you know... So, sorry to interject, but Stack Overflow, the website that has, many questions and answers for programmers, it actually started with the two founders answering all the questions themselves.
Nice.
Yeah, isn't that crazy? So they just... And I think they were talking about it. They didn't even have a website. They had this form where you'd click submit, and then they would create a .html file with your question and answer. That's how they started. And now Stack Overflow is gigantic. There's probably thousands of questions a second, right?
Right, yeah. And I think even you take that example, right? So there's an idea, and you can read a lot about this. A lot has been written, and this isn't exactly an entrepreneurial show. I don't think I said that correctly.
I think it's pretty entrepreneurial.
But, okay, we're kind of, okay, all right. But minimally viable product, that's kind of a word, right? So the idea there is, in fact, don't even make a back end. To Jason's example here of Stack Overflow, whether it be urban legend or true, the internet shall tell way us. But, if you just make a front end that looks like what the website would, people can kind of try it out and test it. You can get a ton of feedback and save yourself days, months, years of development time. So that's kind of where to start. And then, from there, you can Jason will kind of address how does that work? How does one serve millions of users a second? An hour? A day? Millions of users a day. Let's go with there.
So, but to Patrick's point, just to wrap that up, the even when I was making the Trivipedia, that trivia, Wikipedia thing, I started off with just, having just a flat file, and you just scan through that file for everything. So if I needed to find a user by the name, I had to search through the whole file of thousands of users or hundreds of users to find that one. There's no index.
Millions of users?
But yeah, well, that's the thing. So it grew to where, there's, let's say, I think now there's 2,000 monthly active users. And so let's say there's 100,000 users in the system. So I couldn't do that anymore. I couldn't just scan through all the usernames. And so I had to, I ended up making ZombieDB, which is open source. And I think I posted on the podcast on G+, on the podcast's page about that. But so I had to actually make a database. But that came months later, right? And if Trivipedia, if no one was interested in it, then I would have saved myself the trouble of having to make that database, right? And I probably saved myself the trouble of doing other things, which I would have done if there were millions of users, right? So yeah, to Patrick's point, you totally want to start small. Don't worry too much about your server blowing up or anything like that. But now let's answer the question from a tech standpoint. Like, well, how does this work, right? Like, do all these guys like Amazon and Google and eBay, do they all just write JavaScript, or do they, do stuff on the server? So they do things on the server, and it works through a process called sharding. And Patrick has sort of helped me out here, but I'm going to take a first crack at it. Typically, you'll go to, let's say, Amazon.com. What will happen is that'll go to a front-end server. So this server will get your request, and it'll say, and there's several front-end servers all around the globe. So you'll go to the front-end server that's closest to you. So it'll take your request, and it'll say, okay, what servers are pretty, lightly loaded? And the servers themselves, the backends, are constantly telling the front end, hey, I'm not busy, or hey, I'm slammed processing people's orders, right? So the front end server will look for a server that's not busy, and then redirect you to that server. So then your request will go through to that server, which will do all the things like query the database, see if you're logged in, do all that stuff. And keep in mind the database itself is on another server. So you have
set of servers.
Yeah, set of servers. And so there's this other process going on where the database has a front end, which keeps the load pretty balanced among all those database servers. And so this process of having all of these machines sort of working together and having the least used machine, handling your request, is what keeps websites like Amazon and eBay up and running. And a big part of doing this isn't, what we're going to talk about on this show, Hadoop, is more for like batch processing. It's not things that you're going to do, in real time when you're accepting a web request. But just a big part of doing anything on the web or with big data involves sort of managing many different machines and routing work to one machine or the other. So
that's right.
Yep.
And so, and I think there exists server backend technology for many of the most common languages for people to write in. I mean, there's even Node.js, so you can write JavaScript on the backend and use that as a server. You can just like all the major, Java, C++, I would assume C# as well. I mean, there's all these things have back-end pieces that you can write to. There's middleware kind of stuff, let's call it, that handles this load balancing and splitting, and then you write your server and your language on the back. So it's a slightly more than what language to use. It's kind of like understanding this underlying and the problem, but you don't really know where the scaling problem is going to have until you really are kind of almost done.
Right.
So
totally.
Something like if you think about like a Slashdot, let's take Slashdot, right? So they have news stories which are being displayed, but their bottlenecks are going to be very different than a site like eBay, which is handling transactions and a counting down auction, or Amazon, which has to handle when something sells out and they have no more and they don't want to oversell something, right? These things there's amounts of traffic, there's hits on data. I mean, those things are going to have different bottlenecks at different amounts along the growth curve of users. And, on how many transactions are being handled and that kind of stuff. So, you really kind of, if you solve it too early, you risk solving the wrong problem.
Yeah, that totally makes sense. Yep.
So, all right, well, on to our news. So I have the first one.
All right.
Okay, yeah, so I'm doing the first one. I saw an article linked today on Hacker News, which is interesting about the fast Fourier transform. So this is kind of like a FYI. It's not exactly news. It's not something updated, but it was a pretty good article. I kind of enjoyed reading it. So I have a little bit of background with what the Fourier transform is. Yep. So without getting into the deep math, and this guy does a good job of explaining it thoroughly, but not if you just kind of skim read it, you can also kind of get the gist. So Fourier transform.
And there's code too, which is pretty cool.
And he even posts like more detailed. This website's actually very interesting. We'll have to take a look at more and see if there's any other articles that'd be really interesting to you guys, or you guys just take a look and figure out on your own. Yeah. But he covers a wide range of topics. But a Fourier transform in brief is going from the time domain to the frequency domain. So if you have some data that over time changes, so the example he uses is audio recording. So you have digital samples over time, and you're interested to say what are the most common or most prominent frequencies in that sound clip. Mm-hmm. Then you want to transform from that time data to frequency data, which says, at 80 kilohertz. I don't know if that's too high. I'm not good with my audio.
I think that's right.
Okay.
Maybe 40. I don't know.
So, okay,
Close
some number of hertz, that this is the peak signal. So, like, oh, okay, maybe that gives you some information, or you want to do some sort of mutation of the signal and then transpose it back. But this is something that's very common. You'll come across it a lot in a large amount of domains: image processing, audio processing. Even stuff that seems completely unrelated, it can come up. But yeah.
Compression of all sorts and things like that. Yeah.
And this article talks about a specific kind of version of that, the fast Fourier transform, and also the discrete version of that. So going from math to kind of practical there, and a lot of the implications. So it's a pretty good treatment. So if you've ever heard of that and wondered what it was or trying to learn more about it, I would definitely check out this article. It seemed like a pretty good description.
Yeah, it's totally awesome. This is great. I'll have to give this a read. Cool. So I'm doing the next article. It's on the Ouya.
Ouya!
Oh yeah! Oh no, that's that guy who crashes through the window. Or whatever.
The Kool-Aid Man?
Yeah, the Kool-Aid Man. The Kool-Aid Man's coming out with a console.
What?
Pretty awesome, yeah. Hopefully it's like bullshit. And you could pour... But anyways, so the Ouya is coming out. I'm pretty excited about it. I haven't ordered one because Patrick has scared me off of Kickstarter. but I'm super interested in the Ouya. I still might order one off their website, even though the Kickstarter is finished. But
so is it available for ordering off their website?
Yeah, you can actually pre-order it.
Is it the same price? A little bit more?
I'll find out.
Oh, it's okay.
But basically, you can order on the website. It comes, I think, in March or April. But it is for people who missed the episode on the Ouya, it is I guess I'd describe it as an Android-powered console. So it's a console with a controller and all this good stuff, but it's totally Android. So any existing Android games you can play using the touchpad on the controller, and any new Android games will be able to support the hardware buttons of the Ouya. And it's pretty awesome because we've never.
We should say it hooks up to the TV, so it's not like a phone.
Oh yeah,
it's a little box that plugs into your TV, just like Xbox.
Yeah, or PS3 or something. We've never had an open system. So a little bit of history on consoles. The way the PlayStation and Nintendo, Wii and Xbox, the way these things work is, unless you're Nintendo and you're awesome, but let's talk about everybody besides Nintendo. The way that these work is you lose money on the console. So like every time you buy a PlayStation, Sony loses money.
Well, initially, I don't know if that doesn't normally hold true over the whole life of the console.
Because they're cheaper.
Okay.
Oh,
continue.
yeah,
I'm sorry,
see
interruption.
So the point is, they don't make a ton of money. I suffice it to say.
That's not the main way they make money.
Right.
Yes.
So they actually make money by charging developers for a dev kit. So, for example, if you want to make a PlayStation 3 game, then you buy this dev kit, and the dev kit has a little bit of hardware, but I don't even know if they have hardware nowadays. It's probably all in software or firmware. But they'll send you probably a PS3 with some special firmware. But they'll charge you for the dev kit, I think it's like $200,000 for a dev kit. And the only reason why the price is so high is so that they can recoup some of the money. And the idea is, people who buy your game are going to give you money, and you're going to give some of that money, pass it along to the hardware manufacturer.
Well, no, so it's worse than that, right? So it's that for every copy sold, they put DRM on the game. So if you don't have, I guess this is kind of almost slightly different than normal DRM, which is that if I have own media, but that media is not signed by Nintendo, I can't play my media on the Nintendo device.
Right.
So you have to go to Nintendo, and they, I'm doing air quotes here. They test your software to make sure it's not going to break the console or isn't a virus or it doesn't crash. It's good, right? And then basically with their permission, then you can turn around and you're allowed to sell that game, but you owe them X percent or dollar amount.
Oh, that's true. Some
per everything that you sign. Yeah, that's the most. I believe that's like a very common way.
Yeah, I think there's an initial like 100 or 200K investment just to keep like the small people out of the market, and then there's also a rev share. So this is talking to a friend of mine who works for EA like a long time ago, so it might be different now. But yeah, so the point of it is, Patrick and I can't make a game for the PlayStation 3, right? I mean, we just don't have those resources at hand, right? So you have to be a big publisher. or Nintendo has to come to you. Like World of Goo is a common example where they were a really popular indie game. They did really well in Flash, and I think they were out on mobile even before the Wii. And then Nintendo contacted them, and some agreement was arranged, etc. The thing about the Ouya is it's a completely open platform. So like any game that anybody puts out for Android, like Trivipedia, you could play it on the Ouya. Like any Android program out there will run. And so it really just sort of opens up the game console experience to the whole world of developers. And that's what's really exciting to me. So.
And the general trend has been that along those lines, right? So like even the Xbox, there's like, was it Xbox Live Arcade?
Yep.
Okay. Maybe I'm butchering. I think PlayStation has something similar, and Wii U has something similar, and even maybe the Wii did, right? So the main games that you go to, Toys R Us or Target or Best Buy, or I don't know where everybody goes these days, whatever your in your country the local equivalent is to buy a game, right? There's those, which is kind of what we're talking about, but then there's these others, but those still have limitations. Like I remember reading something about when Minecraft came out for the Xbox, right? So they had some people doing this, and then they had an update, and then it was like, oh, if they wanted to update it like a patch again, you're supposed to go through all this testing again, but that testing costs money. So like it's like a thing like you can't. They wanted to just push it early and push it often, but that didn't that was not compatible with how the money was set up, and so it caused kind of a problem.
Yeah. Yep. Totally.
And so sometimes people leave kind of like broken games because they just don't have money to push a fix for it, and that's bad.
And the other problem too is although there is an Xbox Live Arcade, there isn't a developer. There's a developer ecosystem, but not to the extent of these open platforms. Like
could be, yeah.
Yeah, like for example, we talked on last show with that Cocos 2DX, which is it's not a game, it's just a library that you can use to make games. Well, for you to do that on Xbox Live Arcade, I'm assuming you would have to be able to like publish like the library. Like, I'm not quite sure how that would work, but on an open platform, you just give all the source code, and the person can take your source code and link in the Android libraries, and it just kind of works. So the ecosystem is much more healthy on Android.
And so this is a very positive development, right? So like Ouya is on track. They started shipping the developer consoles, which are very similar to the regular consoles, but already kind of like opened up so the developers can do what they need to do, run unsigned code, that kind of stuff. And so this is a positive Kickstarter story.
Yay, Kickstarter.
So hopefully they'll stay on track, and early next year we'll be talking about the reviews of Jason's Ouya console.
Yeah, totally. All right, so I think you have one now.
All right, so
future of the web.
The future of the web would be HTML8. No,
man,
maybe that's far in the future. HTML5.
Yeah, at this rate, that's like the year 3000.
Is finalized. This is one of those stories. I mean, it's kind of interesting just to talk about that. I think it's kind of slow. These ratification of these things, like we've already kind of entered the HTML5 zone in my mind, like it's generally used, right? But yet only just now did everybody kind of agree on what that meant to some extent, which still doesn't really mean anything because all sorts of reasons. But you hear this, like, remember when wireless Wi-Fi in 802.11n was coming out, right? It was draft in. You could buy draft in routers.
Oh, yeah, I remember
and draft in routers weren't guaranteed to be compatible with in. And then, like, a year or two later, right, then it was like, oh, now you can get the actual in ones. I mean, it's just, or I remember, too, like, C++, right, even, that went through this whole thing about, oh, we're going to come up with a new C++ OX.
Took so long,
and it took over 10 years, and then it was, like, finally C++ 11 or whatever.
It's hilarious.
So, I mean, it just sometimes we forget that, like, the world moves on past these standards bodies, but the standards bodies do play an important role in kind of saying, like, this is, what HTML5 really is and really contains. But even then, it's not done. Like, they still have other work to do to kind of make sure everything's okay. It's not like finalized doesn't mean, like, it's done. It means, like, oh, now we can move to testing and compatibility and, actually making it an official, like, HTML5 thing.
Yeah, it's really just almost like a social or political thing. It's basically, like, let's say everyone complains about Internet Explorer, right? Especially older versions of Internet Explorer. Like, Internet Explorer 5 doesn't do what, Firefox and Chrome of the same era do. Or maybe 5 is too old. But you see what I'm going with this. So this is their way of saying, HTML5 is real. You can make content for it. And if someone doesn't support it, that's on them, And so this it's like a political thing to motivate people to switch. And I'm pretty sure if you're using an old browser, and you go to a website nowadays that has HTML5 content, they'll actually have a little link saying, hey, your browser's super old, you can't display this website correctly, and you should go get a new browser. Whereas, before this specification was complete, they would just try and make it support everything. So
yeah, and I mean, we should say also this is by the W3C Foundation or W3C Console. I don't know what the C there is actually. W3C. Oh, consortium. Okay, thank you for saving me.
No worries.
The World Wide Web Consortium. Yes. Okay. And it is a good thing. It is that they've finalized it, and also they've taken time to announce that they've begun the draft of HTML 5.1.
Woo! Oh man, so did they keep the peer-to-peer? HTML5 was supposed to have peer-to-peer support, but no browsers had actually implemented it to this day. But I mean, so basically what that means is you could have a BitTorrent client totally written in HTML. You just go to a website and you just start torrenting on the site. It's just craziness. And I know I read an article where they said no browser will ever support this.
Yeah, I don't know. I don't see anything about it in my research that I'm doing right now.
Oh, yeah.
All right, but it's okay. It's all right. Maybe we'll have a future topic about this.
Yeah, totally.
All right, so I think you're up next. Tell me about some sweet desserts.
Some sweet desserts? Well, I've just been eating some Raspberry Pi.
Oh!
Yes, been eating from the Raspberry Pi store.
You bought Raspberry Pi at the store?
I did. It was delicious. Yeah, it was one of those Safeway specials, but you have to have the card where they harass you, the Safeway Club card. So now it's every time I go, they want me to buy another Raspberry Pi. I'm like, no, you people. So Patrick is dying. So Raspberry Pi store has just launched, today? Or a couple of days ago? But it's pretty cool. The idea is if you own a Raspberry Pi device, you can go to this store, you can download apps, assuming you somehow transfer them to the device. Maybe you download them with the device itself, and you can just start using them. So they have a number of free apps. There's FreeCiv, the Civilization clone, some other free and open source games that seem to be ubiquitous. Battle of Wesnoth seems to be on every possible thing. I have Battle of Wesnoth on my gum sticks, my phone, my 3 computers. So a lot of these open source games, it's just as soon as something new comes out, they try and get themselves on there. But there's a number of awesome things that you can install. Some are free, some cost money. But if you have a Raspberry Pi, or if you're thinking of getting one, definitely check out the store.raspberrypi.com and see what's available.
So is the Raspberry Pi the Ouya before the Ouya?
That's a good question, right? I mean, a lot
it's
of these
a store and a
games.
game, and it doesn't run Android, but shy of that, and it's not nice and bundled, and it's. Yeah,
that's a good point. Actually, coworker of mine, I was telling him about remember the Android stick PC that we talked about on the last show, and how I want to get one for Christmas, and he was saying,
"Wait, do you really think you're gonna get?" I'm just you're gonna buy one for yourself for Christmas?
No,
we should talk about things we want for Christmas. But I normally those kinds of things is nobody really who's gonna.
So this is so my parents, ever since I was maybe 7, they've always just asked me what I want for Christmas, because they don't know anything about computers and things like that. So as tradition holds, my mom asked me what I wanted for Christmas, and
you explained to her go to this specific page.
I had to give her a link. Yeah.
Oh, okay.
I had to give her a tiny URL.
Cool.
But yeah. So my coworker said, well, if you get this, then you're stuck with Android. You should get a Raspberry Pi or a Beagle board or something. And that is kind of true. If you get Raspberry Pi, then you have just a pure Linux shell with you could sudo app, you can install packages, you can do whatever you want. If you have Android, then you're stuck in the Android ecosystem. And so I haven't yet decided which route I'm going to go.
We already sent the link, dude.
I haven't sent it yet.
Oh.
Yeah. Oh, it's sitting in my saved messages but not sent, in Gmail. So yeah, I'm holding on.
Okay. All right. Well, I guess we'll get an update about this. This is the last one we do.
Everyone wants to know about my mom's.
We're recording this before. Well, no, we want to find out which camp you fell into, which you decided, not necessarily which you got for Christmas.
Gotcha.
But I don't know if we'll release this before or after. We're recording this before Christmas. So
that's true. Yeah, we're recording it in advance because we're both going to be gone for Christmas and New Year's. So we're recording some shows in advance. So yeah. So we will find out.
So we will have already known what we will have gotten.
Yeah, when you guys listen to this, I'll be playing with my. Oh, we just caused a quantum. What is it in Back to the Future where you've broken the space-time continuum? I don't know. Anyways,
yes. Time for tool of the show.
Tool of the show. So my tool of the show. This is like the tool that I use more than anything. Like more hours of my day are spent using this tool than probably any other program or anything.
Sledgehammer.
That's a
measuring tape.
Yeah. It's called Choose. No. So my tool of the show is Emacs, and Emacs is a web editor, Emacs is a text editor.
Web editor.
I don't know where I was going with that. Text editor, but it is so much more than that. It has a ton of features, a ton of macros. You can have like 20 files open in the editor at the same time. And you can have infinity files open at the same time. And you can do things like find all occurrences of Patrick and change it to gives Jason a hard time in all 20 files. Like you could just type escape and then find replace all files or whatever. So it has a bunch of like little macro support, and it has all these like cool tricks. It has a color theme picker.
You have colors.
So you start off with like...
You're blowing my mind.
I know, this is insane. You start off with like a white background and black text, which I just can't deal with. So I picked the clarity theme, which has black text, like a grayish, like not completely white because too much contrast, like a nice soft gray.
Coming next week, Jason's favorite Emacs themes.
Yeah, and just a bunch of cool macros. There's an Emacs wiki, which has just a ton of things to make your life easier. Like for example, like just a short anecdote, you might have something like a file which has a number, colon, and then some text. And you just want the text after the colon. Like you just want to get rid of the number and the colon, right? So like if you're just using Notepad, you'd have to do this by hand, line by line, right? But in Emacs, you can just quickly...
Could you just do it from the shell?
Yeah, you could write like a shell script to like, cat the file, go through set and oct and things like that. But in Emacs, you actually do like a regular expression replace, like almost trivially.
Or you could use something that had a column editor.
A column editor? But what if it's like the colon moved to colon because there's too many digits?
That's true. Okay, that would be bad.
Yeah,
that would be bad. All right. You didn't fully specify the problem.
So you can tell Patrick thinks that Emacs is for people who are on magic mushrooms or something.
Come on, man. Where are you going with this? They're trying to make us lose our clean rating. I guess it's still clean, but not like...
What editors are you on, Patrick?
I don't edit my code, man. I just think it.
Oh,
and
really?
Then like...
You write in binary?
I just have telepathy with the computer.
Oh, that's pretty... Do you have one of those headsets? Did you
yes.
That was such a fad.
I know. I wanted to get one of those things that like read your brainwaves and like hack that.
I tried one in Best Buy a year or two ago, and it had this like platformer game where if like you thought about moving right, it moved right. And I could never get it.
But you have to train. I mean, almost all of them have always shown like you have to go through a set of like exercises.
Oh, yeah.
Like the old Dragon dictionary thing where you'd have to like... It would translate the words you spoke or whatever, or write them down. You'd have to read like a chapter of Shakespeare to an act of Shakespeare to like train it. So that's the same thing. Like you need to go through some thing to train it, at least now.
I did that, but maybe like I could be pretty scatterbrained, and so like I kind of think that when I was like I wasn't focusing on the training part of it.
Just remember, there is no game.
There
is no spoon.
There is no spoon. So what's your tool of the show?
Well, okay, so I dodged your question, but I happen to actually be in that weird camp of nerds who thinks IDE is like an amazing invention of modern times, where I can have 20 files open, I can have colors, and I don't need this crazy thing called like these crazy escape key combination macro. That's my camp. Okay. Yeah. I do appreciate that sometimes you have to open up a shell and you have to do stuff there, or you're SSH'd into a computer. Yeah, yes, I understand. But that's like a thing of last resort. Yes. Okay.
So in other words, you're on the 21st century.
Well, I just offended all of our audience. I'm gonna be quiet now.
No, I'm pretty sure I might be the only person amongst our audience who uses Emacs. If you use Emacs,
I think. All right. Here's my thing, and I'm really gonna get in trouble now, but this is okay. I'm gonna say it anyways because that's how I roll.
All right.
So I think people like the idea of being really, really nerdy, so they just say these things and they're not true.
Like what?
Like VI or die.
Oh, yeah.
Emacs server.
Yeah.
I mean, that's not an actual phrase. I just couldn't think of one. But like,
Yeah,
like, oh, I
that's
only use
one.
VI for everything, or like, oh, I only there's like cult of something. I don't know. All these things, right? Like, oh, I only use Emacs, and I'm sure there are people who do, and I'm sure that's legitimate. But I really feel like most people, it's not really true.
Yeah.
Right? Like. Same thing as like I remember there's all these people talk to like, oh, Linux this, Linux that, and it's like, what do you run at home? Like, oh, Windows.
Yeah, right.
It's like I don't have a problem with that. Just like own up. Like if somebody makes something good, it's good. Like you don't have to like, oh, it's made by Microsoft, it must be terrible.
Yeah.
Like come on. I mean, if it's good, it's good.
There
right?
is
like,
a high level of zealotry with Emacs and VI. It's true.
a lot of people hate
doubt.
like the iPhone and the iPad. Like, oh, they're terrible, right? And it's like in reality, like, okay, fine, you might think that, but I think most people just it's because it's Apple.
Yeah.
It doesn't matter if like you could provably show that it was the best thing. Like people would still like, oh, it's Apple, it can't be good.
Yeah.
And then vice versa too. Other people were like, oh, if it was not made by Apple, it's got to be terrible.
Yeah.
So I think nerds, like for some reason, or geeks, like really fall into this trap of like we say we want to be open-minded, we want people to accept our thing, but it's like in reality we try to like
I think everyone is though. Even like you could be. I had a friend growing up who was really into skateboarding, and he was always like, "Oh, you have a Veriflex. That's a piece of crap, just because it's a Veriflex." You know what I mean? So I think everybody who's like really into something has this like brand loyalty. But yeah. So the thing about tech though is tech is very functional. So like to have brand loyalty for something that doesn't necessarily have a style, or where the style doesn't matter. Like it's one thing to be like, I really like, Express jeans, and it's like you do it knowing that they're not gonna like make you walk faster, but it's like, oh, I really like Emacs, and then for Fido was to make the argument like Emacs makes me a better coder, which I don't believe, then now you're putting you're turning something that is like a style, like a personal preference, into like, oh, I'm functionally like a better programmer.
well, but even if people say like, oh, I'm more productive using Emacs than an IDE, but the problem is like, okay, well, like, did you try all the IDEs? Well, no. Did you try one? Did you stick with it long enough? And if you kind of dig, it's like a lot of times like, well, I tried it for like a week and I just couldn't stand it. Well, I mean, did you like pick up Emacs and start using it hyper productively within a week? No.
Yeah,
like,
exactly.
I mean, I doubt it, right? Maybe if you're like some savant, I don't know, maybe, but like, no. Okay, anyways, my tool of the week is Chrome browser sync.
It's pretty awesome.
It's not really like a tool of the week.
It's
I'm
totally
sorry.
a tool of the week.
I totally cop out on all these. It's okay. So I
your
really like this
Snapseed tool was awesome. I'm still using that.
Oh,
I downloaded it during the show.
And you said one of our other tool of the week you were still using.
Yeah, I'm still using KeyPass.
Yeah.
So your
okay.
tools are a winner.
All right.
Yeah.
All right. Better than Emacs. All right. I'm so
I
in
extend
trouble.
the olive branch and I get my hand cut off. Man.
I'm sorry. All right. Anyways, so Chrome browser thing. If you don't know, Chrome is a browser made by Google.
Yep.
And one feature that I've been using Chrome, and I like it. I mean, but I like Chrome. And one feature that I've decided I really like is across my devices. That if you have Chrome and you sign into it, which, I mean, we can get to all the debate, but all right, whatever. So you sign into it, and it'll synchronize your bookmarks. It'll synchronize. You can see what tabs are open from your other computers.
Yep.
And that's like a really good feature. And I think now, like somebody's pointed out, either Firefox ships it like by default or it's an add-on or something. I don't remember. But that browser sync functionality in whatever browser, I happen to use Chrome, so that's my tool of the week. But they may all have it by now.
Yeah, browser sync is awesome. And now
turn it on. It's awesome.
It even works with mobile.
Right. So on my iPhone, I have the Chrome, and I can look at what was that page I was looking up on my computer at home, and I just go like my home computer and like, oh, that tab, bring it open.
It's amazing. Like especially, I notice it a lot when I'm using directions. Like I'll be at home and I'll look up directions for a place, and then I don't want to it's not a big deal to retype in the address, but it's so much easier to just pull up your phone and say, show me my desktop tabs, and the directions are there, like done, ready to go.
But how do you enter all those key combinations for Emacs on your phone?
Oh, dang.
Okay, I'm done.
First
the last one. That was the last one.
I hit
I'm
the
done.
escape key.
I'm done.
Oh, imagine if there was an Emacs editor for the phone, how hard that would be.
It is just a custom keyboard.
Yeah, that's true. You'd need
Custom
a keyboard
keyboard
that had like Control S or something like as a key.
I'm sorry, I'm done with the joke. Anyways, browser sync.
All right, that's pretty fun.
Time for Book of the Show.
Book of the Show.
Show.
That was pretty awesome, Echo.
Okay, I'll go first.
Yeah.
You went first last time.
That Echo. Did you write that in Emacs, or was that a script on Audacity?
I wrote it in C Sound.
In C Sound.
Okay, you guys can look that up
All
later.
right. So,
because you didn't get the joke. So my
should I
was
go
gonna
first?
go first. No, I'm going
you
first.
go first.
So I don't have programming. Jason's is going to be related to our topics. That's why he's going to go second.
Okay.
So I like sci-fi, science fiction,
Totally.
and fantasy as well. This one, it's science fiction, but it's a little bit of fantasy kind of as well, but mostly science fiction. And that is Anathem. This is a book by Neil Stevenson. It's really long.
The whole time
I've warned you.
I thought that I misread this, and I thought it was Anthem by Ayn Rand. I thought that's where you were going with this.
Okay, Anathem by Neil Stevenson.
Sorry, guys. Okay.
It's a really long book. I think it's like bordering on like 1,000 pages or something.
Oh wow.
So here the paperback is 981 pages.
Wow.
So it's really long, but it's really good. So this is going to sound like, Patrick, why is this the best book? You have to stick it out through the first couple hundred pages. First couple hundred pages are a little bit rough, but it is worth it. It's like a huge investment, but like when you make the investment of like, oh, okay, what's going on here? It's really good. I don't want to do any spoilers about what the part of the story, but it starts off and you're in a monastery, and it just starts describing like a whole world which is like slightly different than ours. And like you kind of begin to pick up that there's some things which are different but kind of the same, and it just like really Neil Stevenson just goes into like great detail about like all the functioning of this monastery. And it's not, lest you be confused, it's not like a religious monastery like you would think of today or in kind of our world. So you kind of got to stick with it and see it's something slightly different. And again, I'm trying not to give away because some people, really want to have all that surprise of the book. So I don't want to give more than even the back cover would say. But I'd check it out. It's really good. And like I said, you got to stick it out for the first little bit.
It got good reviews.
Yeah, it's a little... You got to... you just know you're going to read the whole book. Like, just commit, like, I'm going to read this whole book.
And it's only $11. That's not bad. I mean, that's a cent a page?
Yeah, so I mean, you can get on, the Kindle or whatever through Amazon here is like $6.
Oh, even better.
I mean, it's good, or even the mass market paperback. I don't know what the difference is, only $9.
Yeah, right.
So, okay, we're sitting here like reading Amazon prices on the air. This is fascinating podcasting. But check it out. It's a really good, I really like it. And if anybody has read it or does read it after this recommendation, like, let us know, like, any of the books.
Oh, that's a good point.
Like, you should,
for people who bought the book of the previous show and people who buy this book, etc.
Or already have it or whatever.
Yeah, already have it. If you like the book or if you hate the book, let us know. So,
I'd be curious
to see if you have a better book. Let us know. Post on.
Or if you hate this whole segment, or
if you hate the show, post on G+. No, if you some people might be like, oh, head first, design patterns is decent, but I also really like this other design
that's a good
pattern
point,
book. Yeah, feel free to post on the G+ and start a thread where you're only going to help out the rest of the community by contributing.
Yeah, and if you want to leave a really horrible comment about what we should be fixing on iTunes, that's cool. Rate it 5 stars because those are the ones we read, and then just like tear it up. It's fine.
Yeah, if you rate it 5 stars, then we'll mark it as useful.
There we go.
I'm just kidding. Okay.
All right, sorry. So that's Anathem by Neil Stevenson.
Anathem with an extra A.
I'm pretty sure that's how you say it. I'm not
exactly
exactly sure. Okay.
Yeah, well, it's definitely not Anthem.
No.
Because that's missing an A. So, my book is Hadoop, the Definitive Guide. And I've actually been reading this book for a while now, trying to sort of understand more of the Hadoop internals and the way Hadoop sort of does different things on the back end. So as somebody who I feel like I can call myself a MapReduce expert. I might get destroyed for that by somebody who's crazy expert, but I know a ton about MapReduce. I work a lot with MapReduce and Hadoop internals and things like that. So
you just set yourself up. You know that, right?
Yeah, I know. I'll bring it on. I feel like I can take it. I accept the challenge. Unless we get Jeff
Programming
Dean or
Throwdown,
Sanjay Gemawat, the original creators of MapReduce, unless they comment.
That would be awesome.
Yeah, actually, I could take abuse from them. It'd be worth it. Yeah.
You guys, that would be programming throwdown at gmail.com or on our G+ page. Any of you want to say anything? Go ahead.
Yeah. So I feel like I've been doing a lot with MapReduce, and
we could have them on the show to argue with you.
Oh yeah, we should see. They're in the Bay Area somewhere. So
okay.
Yeah.
All right.
So So this book, even as somebody who does a lot of MapReduce and Hadoop, the book was incredibly useful. It's a great reference, has a lot of examples. It really quickly answers the question, why do you use Hadoop, which we'll hopefully answer ourselves. But it explains it in a lot of detail, and it has a ton of extra content. So if you like this show and you're interested in Hadoop and things we talk about, this has a ton of great examples. So.
And it's got a cool elephant on the cover, dude.
It's pretty epic.
It must be awesome. Now, do you know why it has an elephant on the cover?
I think so. Hadoop is the name of the creator's pet elephant toy.
Yeah, like his child's pet elephant toy.
Oh, his child's, okay.
Yeah.
So Hadoop wasn't created by a 5-year-old whose pet elephant he named.
That would be epic.
That would be pretty awesome. You're the most epic 5-year-old ever. So
that was you as a 5-year-old.
Oh, I wish.
Yeah. Okay, on to our programming language.
Hadoop.
Okay, so or I have to caveat that. I said programming language. It's not really a programming language.
No, it's
Hadoop. But that's okay because I noticed our title isn't programming language Throwdown. Only hit me this week. Is that weird?
Totally
You've been doing
true.
23 of these episodes now, and I never hit me when we named the show. We talked about programming languages, but really the title is Programming Throwdown. So I mean, and we're totally in our wheelhouse here.
You could definitely throw down Hadoop versus AllReduce or Spark or some of these other frameworks. So there's a throwdown to be had here.
You already threw it down with Emacs. Now throwing down that you're an expert on Hadoop. Let's bring it.
Yeah, get her done. So. Hadoop.
It's not even that late at night.
Did I tell you I'm actually getting...
No, we gotta say...
I'm real quick.
Okay, all right.
I'm getting a bib. So I want to get a bib for a baby.
Like the kind your hose hooks up to on the faucet?
No, like the kind where they puke and it lands on the thing that they wear or whatever. I want to get one of those, and I want it to say...
For you.
For me. And I want it to say, I ate and made Hadoop. Oh, I'm just getting the stare down from Patrick.
I don't get it.
I'll write it in Emacs.
Let me think about it. Maybe if I start laughing in a few minutes.
Okay. Well, it ends in OOP.
Is it a poop joke?
Yes, it is a poop joke. Okay, now I'm getting a different kind of stare. It's like a despondence. Okay, so let's give some history on Hadoop. Hadoop was based on MapReduce, which was something created by, as I mentioned, Jeff Dean and Sanjay Gemawat at Google. So they created something called MapReduce. They wrote out a paper explaining how MapReduce works, and then Doug Cutting, who is another engineer somewhere in the Bay Area, I think he made a startup. Is that right? He made his own company.
And he's working on an open source version of it. He was inspired by the paper.
Right.
He began working on it.
And then at some point, Yahoo either bought his team or he joined Yahoo. That was sometime around 2006-ish. And so then he kept working on it while he was at Yahoo. So he actually, the whole reason why he created Hadoop was because he wanted to support Lucene, which is an open source reverse index. And we actually talked about Lucene in the mailbag episode of the show, answering the question posed by the person who wanted to create his own, he wanted to index the web for Magic the Gathering. So yeah, Lucene, is a reverse index meant for indexing, thousands, millions of pages. And Hadoop was something that Doug wrote to support that. So at the time, it was kind of meant for that, and it was sort of myopic. But since then, it's grown to an amazingly large scale.
How big?
The largest Hadoop file system that we know of is run by Facebook, and it is 100 petabytes. Do you know how much a petabyte is?
More than a terabyte.
How much more than a terabyte?
100. 1,000. 10,000.
That reminded me of that Monty Python where he's like, yellow, no. So yes, a petabyte is 1,000 terabytes. So all you guys have a terabyte hard drive at home. So 1,000 of those, that's what...
No, 100,000 of them.
Well, yeah, you're right. It has to be more than that.
100,000 petabytes. 100,000 terabytes.
Wouldn't it be
would be 100 petabytes.
100,000. Oh, right. Yeah. So Facebook has 100,000 of those hard drives that they're using to store all their
of the data at least. So it might be replicated.
That's true, right? I mean, that's just one copy.
And that's only what they've owned up to. They may have bigger.
Yeah, that's true.
They may be lying, right? It might actually be smaller.
Yep.
Or it could even be that, somebody else has one that's just way bigger, and they just don't want to talk about it. I mean, this stuff's it's a competitive advantage.
Yeah, it's true. It's true. Okay, so you want to discuss some of the features? What are the things that... So, one thing we should mention in the beginning is Hadoop has become almost like an umbrella term. So Hadoop is the MapReduce for doing this distributed processing, but people also refer to Hadoop as this collection of tools, with Hadoop being one of the things in Hadoop, which is really confusing. But let's talk about some of the other features, some of the other tools that come with Hadoop.
Also, changing my answer again, I was being silly. It's 1024, right? Isn't it? Because isn't it a power of 2?
Yeah, you're right.
We have no idea what we're doing.
Oh man. So yeah, there's.
So okay,
anyways.
so let's do a little bit first. So MapReduce.
Okay.
So we use this term a little
that's
maybe
true.
prematurely. So what is MapReduce?
So yeah, I'll try and explain MapReduce. That's a good point. So first of all, let's do a little bit about distributed computing. Back in the day, people used to do, and they still do, but people used to be totally consumed with MPI and things like that. MPI stands for Message Passing Interface. And so if you had a lot of data and you wanted to do something with that data, you would break the data up into pieces, then you would pass each piece to a different computer, and then the computers would probably send you back some results, and you would put the results together. And then if you passed the message to the computer and it died, your whole process would blow up.
You would have to have code to handle it.
Yeah, or you had to say, oh, this machine died, so I need to pass the message to somebody else. And so you had to be completely consumed with all of these meta things that didn't really matter to solving what you wanted to solve, right? So it turns out that not every problem can be what's called embarrassingly parallel, where you just send chunks of data to different machines. But almost all algorithms can be implemented using something called MapReduce. And so the idea is you take your data, you break it up into chunks. Then for each chunk, you execute a map on the chunk, which takes this chunk of data. It could be a sentence on a web page, or it could be a URL, or it could be any atom of data, and then returns a key value pair. So for example, let's say you wanted to count you wanted for every word on the internet to figure out how many times that word is there. So your map could take a page of the internet, and it could scan through that page and then spit out a bunch of key value pairs, where the key is the word and the value is the number of times you saw it on that page. So if you saw the fox jumped over the dog, then there's 2 those. So one of your key value pairs would be the, 2. Another one would be fox, 1, etc. So now all of these key value pairs generated by all these mappers, they're all kind of floating somewhere in your cluster. So you have something called a shuffle that takes all of the keys that are in common and all the key value pairs that have the same key and squishes them together. So if you have 10 websites with fox as the key, you'll just have one key with fox. And then instead of a value, now you'll have a list of values, where that list is how many times fox was seen on all these websites. Then that's the shuffle phase. Then you have the reduce phase, where you collapse that key list of values down to one answer. So in this example, you would take fox and then 21212324, and you would add up all those numbers together, and you would say for fox for the whole internet it's 13 million or something like that. And the cool thing about this is that all these pieces can happen in parallel. The part that collapses all of the fox values and the part that collapses all the bear values could happen on 2 different machines. And the part that scans website A and scans website B can happen on 2 different machines. And it all just kind of works. And so as long as and the MapReduce code also handles all these things the machine that was processing fox dies, we need to send fox to another machine. They've dealt with all that for you, so you don't have to do it. So that's a short summary of MapReduce, and Hadoop is an open source version of this.
All right.
Yeah.
So part of this is going to be if you're going to. You kind of started with something that was a little bit presumptuous, dare I say, which is you start with everybody reading, all the tasks reading one page of the internet. where do you store something that's every page of the internet? You can't just like store that like on a NTFS or ext. A file partition like this. I mean,
it's so
like,
big.
Yeah, I mean, well, not only the size large, but the number of files is ridiculous.
Oh yeah, right.
So you could run into problems. So I mean, one thing that has to go along with this is you have to have a distributed file system. So first of all, you can't house all the data on one computer.
Right.
But then on top of that, even like how you would access it in a way that is efficient, so that you can have these tens, hundreds, thousands, millions of map threads working on this. You need a way to be able to retrieve that quickly and reliably and in a sharded manner so that that can take place very quickly. And they've handled that as well with the Hadoop file system.
Yep, totally. Yep. So the Hadoop file system operates in 64 megabyte chunks. And that chunk could have one file in it. It could have a piece of a file. It could have 10,000 files in it if the files are very small. And so versus, a regular file system which uses, B trees and red-black trees and things like that. This uses something totally different that's meant for, gigantic files, millions of tiny files, all of these things. And it expects you to access the files using something like Hadoop versus, a file system which doesn't really know how you're going to access the files. Yeah. Yep. There's also HBase. HBase is a column-oriented database written in Hadoop. So, whereas HDFS is a file system, HBase is a database. So if you need to, get rows by key, and if you need to find all keys where the first name is this, if you need to do all the secondary indices, all that stuff, but you still need the distributed coolness from HDFS, which HBase is built on, then you can use HBase and get that. Yep.
So all this code that's running, I mean, if we begin to talk about hundreds, thousands of servers or even more, I don't know how high you could go. How high do you want to go, I guess. You're going to have to have a way to keep that. So machines are going to die. If you talk about that many machines and some of this data can take a long time to process, I mean, machines are going to die. You might want to add new machines. You want to increase your capacity. I mean, that would be a huge mess.
Yep.
In the olden days. Where back in the day? No, I mean,
yeah. Imagine if you're doing MPI and you
have
have to deal with that, right? I mean, it would take you months to have to deal with this machine died, so I'm going to send it to that machine, right? I mean, it could be such a nightmare, right? Or what if the machine that's sending the things dies? I mean, you don't want to have to restart the whole thing just because of that. So dealing with that, right? Yeah, that could be a nightmare. And so Hadoop's thing which handles that is called Zookeeper, all going along the lines of like pet animals and things like that. And so Zookeeper is a distributed coordination service. And so in like really short, what that means is somebody can write some data to Zookeeper, and somebody else, if they try to write data and the data collides, Zookeeper sort of figures all that out. So that if two machines both want to take the same job at the same time, Zookeeper says, no, look, only one of you guys get this job. Things like that.
So like we said, I mean, Hadoop is kind of, when people talk about it, they're kind of talking about all these kind of tools, which are kind of all necessary to get together and enable you to be able to run those map reduces. Mm-hmm. And so, I mean, kind of now talking about the strengths, one of the things like we talked about is you bring up more computers, great. You can have more threads, and the threads can run sooner. They don't have to be serialized.
Yep.
And so, I mean, you can just scale this ...
Yeah, totally.
Just, whatever, like however much, I guess, time or money you have exactly. Determines, how big you can go, or you need to go, or have to go.
Yeah, it's amazing. I mean, you could be using the Amazon Web Services, which run Hadoop.
Right, so they have a version that they've altered, I guess, or changed.
Or it's not Web Services.
Elastic MapReduce or whatever, right?
Yeah, right.
Which is very similar, yeah. So they have their version which runs on their infrastructure. So they have, for instance, they may not, I think the way it works, I'm speaking a little out of my expertise here, but it's, instead of having like a Hadoop file system, they have their version of the same thing, right? Their elastic file storage, which they kind of hide from you, so you don't have to worry about it. You just put data there, and then you can run the Elastic MapReduce, which runs on that. So it's very similar and shares a lot of stuff with Hadoop, but it isn't exactly the same.
Yeah, totally. I don't know if it uses the same API or how that works, but
I don't know.
Yeah, but
didn't look into that.
No, I haven't done that with Amazon. But the the other cool thing is it's fault tolerant. So all these crazy corner cases that you'd have to code up yourself, they've done that for you, and they'll even do crazy things that you wouldn't think about doing. Like one thing Hadoop will do is, let's say you have 20 machines that are in your little Hadoop cluster, right? And you're running a job. And Hadoop detects, the zookeeper detects you're only running one job. And the job had 8 workers, like 8, let's say there's 8 mappers. So Hadoop will say, well, if one of these machines dies, you have to start the whole thing over again. So let's just run, since you only have 8, let's just duplicate all this work. Run it on 2 machines, and if one of them dies, it's okay. Or another thing they'll do is they'll know, you might be able to pass some data, or you might be able to arrange and do a little bit of the reducing in the mapper. These crazy optimizations that we don't really think about because we're too busy focused on the algorithm. They've done all that grunt work, and they've done all these awesome optimizations, sort of like using C++ instead of assembly, right?
Exactly the same.
Yeah, MPI is so low level that you just have to end up doing way too much.
And that feeds into one of the features I skipped over that you were particularly a little bit passionate about, Crunch.
Oh yeah. So you want to talk about Crunch? Patrick's actually used Crunch quite a bit.
Yeah, well, you overstate, sir. I'm not so emblazonedly bolden to say that. But okay, not to call you a liar, but I'll just okay.
Yeah.
So what Crunch is Crunch allows you to instead of having to use the kind of off-the-shelf nature of a lot of the stuff that MapReduce does, or kind of fit into their paradigm, kind of even going again on what Jason said, extending it even a little further, even more flexibility in how you do these things, and it just allow the computer to handle it, right? The computers to handle it. Just you take care of this, right? So Crunch is an API for allowing you to, at an even higher level, say here's generally the data flow I want, and here's the operations I want to perform, and all right, go. And so if you kind of drew out I need the data, these 2 data things need to flow together, I need to do some operation on them, and then once that's done, I make some calculation, and then I need that to flow with another piece of data, and then I want to kind of join those together in an inner join fashion or something, right? All these kinds of notions could become, they're multiple MapReduce Hadoop jobs that would need to run, and there are things that you might have to string together very carefully. But Crunch allows you to just kind of specify these are the way I want it to do, and it'll handle I could merge these 2 together and run them at the same time,
Yep.
Or I need to spin up a new Hadoop run for this thing or for that thing, and it kind of allows you to do that much more simply and easily, and in a way that's flexible, just allowing the computer to handle it.
Yeah, and Crunch feels more like Java, because you have these P tables, which are basically they feel a lot like hash maps in Java. So you can kind of take your existing Java code, and if you need it to run on 1,000 machines, it's not just a copy paste, or you can't just change hash map to P table. There's more to it than that. But it has things like get all the values, get a list of all the values. That exists in hash map and also in P table. And so it kind of feels more like you're just doing native Java. So it's good for people who want to get started with Hadoop and aren't used to writing this kind of stuff.
Yeah, it's that idea P table or P group table, and it allows you to say and everything in that, in parallel do this thing, right?
Yep.
Go through and perform some operation. So that's what I was kind of talking maybe a little bit too high a level.
Yeah.
But that's how, you kind of, it gives you this API, but it really is kind of almost classes and things that make it just look like, to Jason's point, it looks like you're writing Java code on some fancy, hash map, and in reality, you're instructing Crunch to, in the back end, figure out how to arrange the MapReduces and to be able to do that.
Yeah, totally. So there are some weaknesses to MapReduce.
No.
I know.
After we sang the praises?
You think it would be just a panacea that would just be a cure-all, but no. One of the problems with MapReduce is it takes a long time to spin up and spin down. And so what we mean when we say that is spin up refers to, for example, let's say you're building a multi-threaded program. So the first thing you'll do is make the thread pool and actually ask the operating system for the threads. So that's kind of like our spin up time, right? And so to ask the operating system for some threads happens in what, milliseconds, maybe even less than that, microseconds. But to ask MapReduce for 100 machines to do work on, or to ask a Hadoop zookeeper for 100 machines is going to take on the order of seconds at least. I mean, it really just depends on your cluster, but it's not going to take milli or microseconds, right? So if you have, a MapReduce job that adds two numbers, goes through two files and then adds the numbers together, and the files are a meg each, you might just want to do that in C++, because by the time you spin up the machines, send numbers to the machines, and then compute the result and then store the result somewhere. Yeah, your C++ program would have run like 40,000 times or something. So there is a problem there. Yeah, there is something called worker pools, and the idea is, if I have a job that I want to run over and over again, I can sort of prep Hadoop, and I can say, look, Hadoop, you're going to do this thing 100 times, so get ready for that, and then it'll do some optimizations there.
Also, we talked about all these wonderful things of bringing on new computers and bringing down computers and all these stages and divided, and just, do this little bit of work and then do this little bit of work, and that helps it be really scalable. But, I mean, as you can imagine, all the data that's in your program, all those classes and everything need to be able to be serialized out. And then when they're read back in, they need to be deserialized. And sometimes, it can be said, I'm going to do this on the same machine. But a lot of times you have to do it anyways because you don't know, am I going to be doing this on the same shard or not? Or is it going to go somewhere else?
Yeah.
And so it's just, if that takes a long time because you have especially some nasty intricacies, it could be a problem. But even just in general, that's going to be overhead. Yeah.
And then the other thing, and there's some theoretical reasons why this is true that I'm not going to get into because it takes a long time, but there's a lot of materialization. So, each of your mappers, going back to our word account example, each of those things that scans one page of the web has to put those results, all those key value pairs, on disk, on that Hadoop file system. And then the reducer, the shuffler, that's putting together all the keys has to read those from disk and then put the reduced key values lists on disk. And then the reducer has to read from disk and then put the answer on disk, right? If you were just writing some C++ program, you would just put everything in memory. Or maybe you would only put a bit of that on disk, like one stage of that on disk. So there's a lot of disk I/O when you're using Hadoop. There are some tools to sort of make Hadoop a little easier to use. One of them is Pig and Hive, and so they're good for if you don't want to have to write Hadoop, like raw Hadoop code. You can just put your data in Hive or put your data in a flat file, like a text file. Then you use something like Pig or Hive. They have their own programming languages, which are much more terse than Hadoop.
Yeah, I mean, with a lot of these things, that's planning can take a long time even, right? It's like figuring out, how exactly do I want to divide my data?
Yep.
Getting my data into the right place in the right format. That can take a lot of time.
Yeah, totally.
And so these tools will help you with that.
Yep.
We have Avro. I have no idea what that does, so that's going to be all you, buddy.
Oh, Avro is like Thrift. It's like a serialization.
Oh, okay,
thing.
Okay. All right.
Yeah,
we talked about this. Okay.
Yeah, totally.
I'm reading your point, so.
No worries. So what is Hadoop used for? What is MapReduce used for?
Everything.
I think there was in the white paper on the original white paper on MapReduce, they said that it was, I don't remember, I think it was over half of computations at Google were part of a MapReduce. I think it was some very large number.
Oh, interesting.
But yeah. So, and Google is like a huge company, so and I'm pretty sure Facebook and all these companies have probably similar statistics.
It's kind of interesting to see what companies will say what, right? It's kind of like a little bit of a game, like, oh, hey, we're doing this.
Yeah.
Well, we're doing, but it's like, who knows, like what percentage of the actual value those things are? They're just like kind of one-upping each other.
Yeah,
but only
true.
Like slightly, and the others are just keeping quiet in the corner. And it's like, oh, are they embarrassed? Or like, do they like, oh, this is ridiculous, and just laughing, right? Like,
yeah, exactly.
It is kind of interesting. But I mean, no, seriously, MapReduce, it pops up all over the places. Like, even for doing like image processing, like, oh, you want to like do a whole bunch of, look for objects in something, or you want to run the same little algorithm on things. I mean, people have done MapReduce to do that.
Yep.
People have done MapReduce even for like, I saw one guy was writing a little bit of tutorial, like, I think he was trying to convert like old PDFs and like do OCR on them. Like you had a whole bunch of them. Like each page of old books that had been scanned was like either just an image or a PDF. And you want to do like OCR on all of them, right? And like then put them somewhere. But like you could imagine, like if you have millions and millions of these pages, like, it would just be a nightmare to figure out like a C++ framework and structure, or Java, structure to kind of do that. That could just, it could take a long time. But that's right in the wheelhouse of MapReduce.
Yeah, totally. Yeah, there's a ton of things you can do with MapReduce. The biggest thing is, especially as sort of like, let's say you're an indie developer, you're just writing code out of your house, right? But you want to do really big data kind of things. Like, for example, let's say you have a website and you have a few thousand people on your website and you're capturing all their clicks and things like that. Let's say your website has 1,000 people a day, and each person like on average there's 1,000 people, and each person clicks once a minute. So there's how many minutes in a day? I don't know.
Let's just say they click once in a day.
Okay.
So you have 1,000 clicks a day.
That's still 30,000 clicks a month. So if you wanted to go back through a year's worth of data, that's 365,000 clicks. That's a lot of data. And so, you don't even want to do that on your machine because it's going to take forever. So if you wrote a MapReduce, you could say, run it on your machine on like 1 day's data, make sure it works. And then say, look, Amazon, you have this elastic cloud that's totally awesome. Chug on this data, like run this MapReduce that I wrote. And Amazon will charge you however much that costs, maybe $5 or something.
Sure.
To run
or you do it accidentally the wrong way, and then.
How do you do that?
I don't know.
Okay.
You just like accidentally misconfigured something, and like it's really big. No,
and then they charge.
It's like some really outlandishly large number.
Oh no! I hope that doesn't happen.
You probably can set a budget. I'm sure.
Yeah. But yeah, and then all of a sudden now you can run that same program on 1,000 computers that you don't have to own. So it's pretty awesome. Yeah.
All right. Well, I think that's a wrap for this episode.
Yeah, Hadoop is great. Learn it. It's fantastic.
We hope you will have had a good Christmas.
Oh yeah, that's right. Yeah, in the future, we hope Christmas will be awesome.
Will have been awesome.
Will have been awesome. That's pretty wild.
I don't know. All right. Till next time.
See you later.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.